In this video, we are going to learn about the composition of a trig function with its inverse. So what does that mean we're doing? We're going to evaluate an expression with a trig function and its own inverse. Hint, they cancel each other out. But we have to be mindful of the domain and range restrictions when we're dealing with inverse trig functions. So here are the rules. So first thing you want to know is that a trig function and its inverse are going to cancel each other out. However, your answer is not always just like what it is on the paper because of the fact of rule number 2. Inverse trig functions have restricted domains and ranges, and your answer must or needs to fall in the domain or range restrictions according to the function you are evaluating. So that means, I made this table for you, that you have to pay attention to the fact that depending on if you're looking at inverse sine, inverse cosine, or inverse tangent, and you're evaluating, you have to pay attention to where you're allowed to evaluate. Otherwise, we say that our answer is undefined because it's not part of here. Now, why are my inverse functions trig functions? Why do they have restricted domain and ranges? It's in order to make them an actual function. Otherwise, they wouldn't pass the vertical line test. So we restrict the domain and ranges to make that a function. So the best way to do this is to look at a couple different examples. I have one sine, one cosine, and one tangent example, and kind of 3 different scenarios on what can happen when you're solving these kinds of problems. So the first one is asking to evaluate the inverse sine of the sine of 10 pi over 9. Now we're dealing with sine, so and we're looking at our range of our inverse, because we have to look at the range of the inverse sine because ultimately we're dealing with the second function, the bigger one, this one right here, sine. And so we want to make sure that we're plugging in a value that's going to give us an answer in this between negative pi over 2 and pi over 2. Okay, so what we want to do first is we want to figure out where is 10 pi over 9. So if I'm looking at 10 pi over 9, I start here. 9 pi over 9 would be the same as pi, so it's going to be past pi, so I'm kind of coming, I don't know, somewhere right around here. Doesn't really matter where you mark it on your unit circle, just so you can give yourself a ballpark idea as to which quadrant you're in. So I'm looking here. So this is going to be 10 pi over 9. And I happen to notice that 10 pi over 9, if I just looked at this and say, oh, well, these two cancel, 10 pi over 9, well, it's not in my range for the inverse of sine. So that becomes a problem. So here's what I have to decide. Because it's a unit circle, we can find other values that are going to give us the same sine value. So we just have to figure out where that is. And the reason that is because sine is a periodic function. It repeats. So I know that here I look at all students take calculus. And in my third quadrant, which is the one I'm looking at right here where the T is, I know that if tangent is positive, that my sine value here, sine is negative. So I need to look which quadrant of my inverse sine is the negative one. This guy right here. That's where sine's negative, and on the top is where sine's positive. So that means that my answer has to be in this quadrant 4. So I basically have to come down here and find this angle right here that's equivalent to this angle over here, and that will be able to give me my answer for evaluating this problem. So what do I have to do? I have to find out this distance. What is my angle here, or my reference angle? We know that this is pi, so I'm going to say, well, I'm going to take 10 pi over 9, and I'm going to subtract pi. So to make a common denominator, I would have to multiply the top and the bottom both by 9, and 10 pi minus 9 pi is equal to pi. So this angle right here, we'll color it in purple, is going to be pi over 9. So now I know I have to, from my 0 value, get down this way, go underneath. So down would be negative. So I'm actually going negative pi over 9 to get to that place. Same spot in my unit circle, that would give me the equivalent inverse sine value. So my answer here is going to be negative pi over 9. Okay, next. Okay, the inverse tangent of the tangent of negative 2 pi over 9. So where is negative 2 pi over 9? Negative 2 pi over 9. So I'm going to go start here and I'm going to go down. So negative 2 pi over 9, probably somewhere right about here, just a ballpark. So I'm looking here. Okay, so do I need to know what negative 2 pi over 9 is when I take the tangent of it? No, because my inverse tangent and my tangent, they cancel each other out. And because this negative 2 pi over 9 is in my restricted domain and range, my restricted range for my tangent, which is up here, and note that this is only parentheses, by the way, not inclusive, then I can say, well, here, my answer is just going to be negative 2 pi over 9 because it happens to fall in my restricted range. So I don't have to do anything additional. Now, the last one's a teeny bit different because you'll notice that we have the inverse cosine first. So I have to first, I'm going to just check this to see, well, is this going to give me a value? It doesn't matter what the value is. So the inverse cosine of 2. So I'm going to come up here and I'm going to check in this line right here. Can I evaluate the inverse cosine of 2? So the question is 2 fall under my restricted domain? Nope, it does not. It's outside of my restricted domain. I can't take the inverse cosine of 2. So that would be undefined. This part right here would be undefined. And we can't take the cosine of something that's undefined, so this answer is ultimately undefined. Okay, final answer. So you want to be careful. So look at the function that they give you first, just as a general overview. If I evaluate it, am I going to get an answer? Okay, is that within my domain and my range of the original function? Then you want to look at the function on the outside. Are you dealing with the inverse on the outside? If so, make sure that your answer is in the restricted range. Let me know if you have any questions or you need any additional examples. Good luck.